Okay, today we're going to talk about the order of operations. That is, there's a universally agreed upon procedure for evaluating a large number of computations. If you have a big expression with additions and subtractions and multiplications and divisions, the question is, which one do you do first, which one do you do next? If different people do things in different orders, they can get different answers. And in mathematics, we always want everybody to agree on the same way of doing things so that we all get the same answers. Some people say PEMDAS. Others remember these letters PEMDAS as please excuse my dear Aunt Sally. Anyway, it's a silly thing, but it's a way to remember that the order of operations that everybody uses is PEMDAS. The P means parentheses. We always do things in parentheses first. You'll see me in class use, well, actually I don't do things in class, but you see me on these lessons using a lot of parentheses. You put parentheses around anything that I want to be by itself. You can use parentheses to isolate things, to insist on that being done first, because that will always be done first. The E stands for exponents. You always evaluate exponents before you do anything else. Now, MD, multiplication and division go at the same time. You go from left to right, you do all the multiplications or divisions, whichever one comes first. Some teachers teach you that you do all the multiplications and then you do all the divisions. That is completely wrong. As we talked about earlier, multiplication and division are basically the same thing. So there's no way you can really differentiate between one and the other. They are the same basic operation. You don't differentiate one or the other. Same thing for addition and subtraction. Addition and subtraction are two different kinds of the same basic operation. You go from left to right. If you see a subtraction first, you do that. If you see an addition first, you do that. So, but a lot of people are taught this wrong. You might very well have come from a class where your teacher taught you incorrectly. For example, some people might say that if you have 15 minus 3 plus 7, a lot of people really want to say that this is, well, 7 and 3 is easy, that's 10, and then 15 minus 10 is 5. That is wrong. You go left to right. The first thing you do, you see this first subtraction, 15 minus 3 is 12, and then you do the next operation. So this is the first operation, and then the second one. They are addition and subtraction, so you go from left to right, and then 12 plus 7 is 19. What is really happening? What really we can turn everything into addition, because addition and subtraction are basically the same thing. This is like 15 plus negative 3 plus 7. And now you can do it in any order you want. You want to do these two first? Sure. That's going to be 15 plus, what's negative 3 plus 7? 4. That gives you 19. You want to do the first two first? That's going to go this way. 15 plus negative 3 is 12, and 12 plus 7 is 19. So you get the exact same answer both times. One thing, so another example is, well, that's not doing. Another thing that, well, some people say, why not do everything left to right? Left to right. That's a fair question. Why not do everything left to right? Why do we have to have this hierarchy of things? Well, because if you buy, let me just say, if you buy 8 pencils for, let's say, 39 cents each, and 5 notepads for, let's say, 99 cents each. What you get is, how much does it cost? The cost is going to be, we have 39 cents 8 times, 39 times 8, and then we add to that 5 times 99. We want to do multiplication before we do addition. If you did this, if you want to write this from left to right, there is no way you can write multiply the 8 and the 39 first, and then multiply the 5 and the 99 second, and then add them together. There's absolutely no way you can do that purely from left to right. Oh, you can use some parentheses, but again, you want to start using parentheses, it means you're talking about parentheses being the most important. It means you're talking about order of operations. There's one thing that can cause some trouble for some people, and that is what I call invisible parentheses. Mathematicians are really, really lazy. We skip parentheses a lot of the time. If you have 4 to the 2 times 3 power, now we're supposed to do exponents before we do multiplication. Okay, so we do the exponent first. But what is the exponent? Is it 2? Is it 3? It's 2 times 3. The invisible parentheses are around that. The invisible parentheses say, I know we do exponents first, but to figure out what the exponent is, we're going to have to multiply. We have to say this is 4 to the 6th power. Oof, that's a large number. That is 4 raised up to the 6th power is 4096. So, exponents sometimes are in parentheses. You have to evaluate an exponent before you can use it. So in that sense, it looks like we're multiplying first. There's sort of these invisible parentheses there. Another place for invisible parentheses is in fractions. When you have 10 over 2 plus 3, what it means is there are invisible, this bar goes all the way across over the 2 plus 3. The 10 is being divided by what? The 2? The 3? It's being divided by the sum, by 2 plus 3. This is 10 over 5, which is 2. You say, well, wait a second. That bar means division. Aren't I supposed to divide first? Yes. What's really going on? There are invisible parentheses there. There's invisible parentheses up there, but 10 is just 10. We don't have to do that. But this bar kind of comes with parentheses in it. It's a very common mistake to type into a calculator 10 divided by 2 plus 3, thinking that they're figuring that out. But really, in this situation, you do the division first. And so this is 10 divided by 2 is 5 plus 3 is 8. But that's not the same. That is, in fact, what we call different. So you have to be careful about that. There's these invisible parentheses. Anytime you're dealing with a fraction, you have to evaluate the whole top and the whole bottom before you divide. Anytime you have an exponent, you have to figure out what the whole exponent is before you can raise it up.